Welcome back. Today we need to make a bunch of these plastic discs. These are made out of PVC. Final thickness is around 11 millimeters. Diameter is about 140 millimeters. Just to give you an idea about the size. Has a board feature here. An O-ring groove on this side. Another groove on the OD on this side. This is not for an O-ring, this serves a different purpose. And we have 3 holes going into the part radially. And here we have 2 holes crossing the outer 2 of the radial holes. So basically another very complicated part, but somebody still has to make them. So there are 2 ways to tackle this. You could buy round stock 150 millimeters PVC, bandsaw or part it off and then go from there. But I usually make them from plate, sheet stock. Normally I buy square pre-cut blanks. The plastic dealer cuts them to size for me, and I trepan the disc out there on the lathe. But I had a large sheet of 12 millimeter PVC that I don't use for anything. I bought it for a prototype once and I wanted it to be gone. So I went to the bandsaw and cut some rough circles out of it. I just used a silver streak pencil. These work very nicely on black materials for layout. You get these in, obviously, in the welding supply. Just used my sample part as a template, dropped on there, drew a circle, bandsawed it out roughly. Next we go to the lathe and we turn the OD. And for that we need the center of this piece. How do you find the center of a circle? That's easy. You measure your diameter of the circle, which is around 145. You divide 145 by 2, then you get the radius, which is 72.5, and you set a pair of dividers to that radius. About like this. Doesn't need to be crazy precise because I have plenty of stock on here. And then you just go here and you poke the dividers into the circle and scratch a line. Hard to tell. There we go. Then you do it 2 or 3 times more, maybe 120 degrees offset, roughly. Ideally, all these lines would meet in the same point, which they don't because the circle is just traced around the template very, very quickly. But we still... Let's try to highlight these. That's better. But we still can identify the center of all these arcs that we drew, and that's right in here. That's where we need to put a center with a center drill. So we can put these on the lathe and do a pressure turning operation. Okay, we're over the lathe, and I have the regular 6 jaw on the machine, and I have this aluminum faceplate. This is a sacrificial faceplate where I just drill and tap whatever holes I need, and I'm just holding this in the 6 jaw, taking a very light skim pass so it doesn't wobble all over the place. So we bring the tailstock in. We have our center, which mates up with the live center in the tailstock, and we push the part up against the faceplate. But just by doing it like this, it can't transfer much torque there is friction. You can perfectly turn with the setup, but if you take a somewhat heavy cut like I'm intending to do, like one pass, it will slip. And that's rather annoying, especially with PVC, as it tends to melt immediately when you heat it by friction. So we put this non-stick foil on here. This is now sandwiched between the raw cut circle and the faceplate. And now if we give some axial pressure on the tailstock, this is not going to move. No chance. Before the material will slip on this non-slip foil, something really bad needs to happen. I'm not planning to find that to do that. So here is our CNMG turning tool. And I'm going to turn these a little bit oversized because I'm going to put them in soft jaws later and finish them that way. I need to change the insert. This is a CNMG insert for stainless steel, and this doesn't do very well in PVC. This is not the direct screwed insert variant. This has this toggle lever that's actuated by a screw on behind the insert. Make sure the insert pocket is clean before we put in a different insert. Find an unused corner of this insert, put it in, push it back into the seat a little bit, it helps. There we go. Okay, now as we turned all of the round blanks, we need to proceed on. I have my soft jaw chuck on here with a set of large pie jaws. They are bored to 142 millimeters, and also a second step up here with 143, which is the diameter of the blank. And the step up here is only 1.5 millimeters deep. So the blank goes in here, up against the back of the step turned in, and now I have enough material sticking out of the chuck to do all my side one operations. Note that I have the center that we drilled previously on this side because this side gets bored out. I'm using a CCMT turning tool. This is not this is a reground insert. I made a bunch of these some time ago. It's just a regular CCMT insert for steel that's surface ground completely flat on top. I will show a close-up later. Over the time I figured out a good order of operations to do these parts as quickly as possible without moving the tool unnecessary back and forth, and keeping the tool changes themselves also at a reasonable number. So first we will start to turn the OD. This is quite nice because I have all my dimensions in the DRO. I just have to move the slide here to the right numbers and have a go at it. There we go, that's the OD and the stringy mess of chips. Quick idiot check, just to be sure. Yeah, that's 142 and some change. Now we need to turn a step. That's just to remove material. I'll let the machine run a little bit slower because I'm creating a very wide chip and I don't want to get that all over the place. Okay, turned this diameter, and now it turned to my C depth, and now I'm going to retract the tool and clean up the face here. And PVC is really atrocious for its chips. It's really hard to break them in this material. Okay, last step is to face it off to final thickness. So after facing, we have the X slide all the way in. And while we're here, we can do the boring operation here. And then when we move out, we do the face grooving. But first we do this side here, or this area here, because we're already there. We start with an ISCAR inserted drill and boring tool. This can drill into solid stock. And it can also do boring as just like a regular boring bar. That's the 9mm deep bore. Now we switch to a smaller boring tool. I'm using this instead of the ISCAR insert drill because this leaves a sharp internal corner. The ISCAR boring tool has a significant corner radius, and there is a part that gets glued into this corner bore we're about to turn. I want a reasonably sharp corner there. And again, once I turned the ID, I'm doing a facing move with the tool in X direction to clean up the floor of this counter bore. So our next tool will be a face grooving tool. This is ground on a deep bit grinder, and it has a width of 2.5mm. And this is our final tool change. We go back to the OD of the part, pick my correct tool on the DRO, the slot needs to be wider than 2.5mm, so I'm offsetting to the outside. And also when I plunged in, I didn't finish the OD of this hub here, so I'm going to do that now. Okay, there is our face groove. Check the depth. Should be there's a burr. We deburr it with a 4-sided carbide scraper. Pro tip: take the tool out of the tool post before you do any scraper work on the lathe. And then some 3/0 steel wool. And on PVC I noticed that if you use it dry at something like 600 RPM, it tends to melt the material. I wet it with a little bit of alcohol, and this helps. There we go. The steel wool just deburrs the little chamfer from the carbide scraper and just evens out everything a little bit. Just a nice touch. I do that almost on any turned plastic parts nowadays. I think I learned that from Robin Hood City once again. We got a fairly nice finish, and the face groove doesn't look too shabby either. Face groove should be 4.7 millimeters deep. 4.69 is okay too. Got all 12 parts done on the first side. That's the side with the bore, face groove, and we still have a lip down here of about 2 millimeters that are unmachined. Now we flip the parts around and drop them in the soft jaws. Again, face off the back side. We need to cut another face groove here, and then they are done on the lathe, and we only need to do some drilling. Now we're running the back side of these parts. I drop them in the soft jaws that are bored to this diameter here. That's the finished diameter. We drop them in, clamp them lightly. We don't need a whole lot of cutting pressure here, clamping pressure, because the cutting forces are relatively low. I'm going to face it off with a custom carbide tool. That's the tool I'm using. That's my 45-degree chamfer tool, and I just lapped a nice radius on the end, so it leaves a very decent finish at a reasonably high feed. I'm feeding this at 75 microns per revolution. So it's not crazy fast, but for a fine finish with a small nose radius, that's too fast. And I'm using compressed air to get rid of the chip right away off the machine. Different tool, roughing out the step, roughing out the shoulder here, and finishing it. There are almost always issues with long stringy chips when machining PVC. It's just a nightmare. Next tool is our face grooving tool. Okay, that's turning done on this part. Last step is the square scraper. And some steel wool. Yeah, now that's a decent finish here on PVC. That's also the reason why I'm not milling them on the CNC router. It would probably be faster to cut them on the router, but this finish here, this is the customer side of the part. This is what the customer sees all the time, so it's nice if this is looking good. Got 12 of these covers machined, all done on the lathe. So first side, second side with the counter bore. And now we need to drill them. The holes we need to drill, there are 2 here and 3 that go in radially into the part. And in the past I did this with the Walter dividing head and the soft jaw chuck on the mill. I have a picture here that shows the setup. This works very well, of course. The dividing head is just a very good setup, but setting it up that way takes quite some time. You need to get the dividing head up, mount the chuck, and so on and so on. And I make these parts frequently enough, so a separate fixture is a good idea maybe. I have already a fixture here, And this is for drilling these axial holes here. These need to intersect with these outer two holes to form a channel that goes all the way through. And the way I aligned it, when we put this in here, the XY location of the part is set by these 3 pins here, so it cannot move. But rotational, that's not helping us. But we have this central hole here, which is a 5mm hole, and I have a pin, a 6mm dowel pin, that's turned down to 5mm, and this goes in here, and it's fenced, it's captured between those 2 pins. And this gives a very accurate setup, so I just need to center in here or on the OD and move my XY over and drill those 2 holes. You don't even need to clamp the part down, I just hold it by hand down and drill. So this works exceptionally well, and the chain is only here so I don't lose this pin. And I figured I'd build a fixture to drill the radial holes the same way. The part is again captured between 3 pins. Then I use a Y-script to clamp the part, drill the 5mm hole, put a long 5mm dowel pin in it and capture it in between those 2 positions here and here to get my, I think it's 20 degrees offset for the other 2 holes. I laid all this out in CAD. I also have a chunk of aluminium. This is some tooling plate which is from the factory surface. These are reasonably flat for some rough fixture building, and we'll go from there. The slot up here is, I will machine that in the same setup I drilled the holes to give me something to center an edge finder. So let's make this fixture quickly. It shouldn't take too long. It's just drilling holes and milling the outside of the plate. First we start by cutting the plate parallel on its long sides. For that I'm using a 50mm face mill here with some round inserts for aluminium. That's, by the way, a super cheap cutter from China. This cutter costs like 20 bucks, but the inserts that came with it were purely crap. But I put some high-grade inserts on it. And okay, drop the plate in for the second side. Make sure it seats properly on the rails of the vise down here. Drop the cutter another 0.25mm and clean up the second side. That's really an okay finish. I'm running at 1500 RPM and about 400 millimeters per minute. If you wonder what's written on this brush, only 4 machines. Don't use the same foxtail brush or whatever to clean dirt from the floor and to clear chips off your machine. Otherwise you will get things like sand or small stones onto your machines. Same thing when you use a brush to clean a grinder. Don't use the same brush for grinders and your usual machines, or you will carry over grinding dust to your regular machines and cause additional wear. There we go, 2 parallels. Part in here. And now in this setup I can mill both ends square to the sides I cut previously, cut my notch to center it later when I use the fixture, and drill all my tapped holes. Drill all my holes that get reamed. Okay, I got all the pins in, and it seems to fit together after my practice part here. It aligns, and the way this works now, you put this in the mill, you clamp the part in here with vice grips or C-clamps or whatever. You drill your 5mm hole up all the way to the center of the part. Then you loosen your clamps here that's holding the part for drilling. Then you rotate the part over, take a pin, go between those two fencing pins, clamp it again and drill the 3mm hole up here, about 33mm deep. Then you pull the pin, you rotate the part over to this fence, put the 5mm pin in again, and drill the 3mm hole. Then you're done. Then you go to the other fixture and drill those 3mm holes that go axially into the part. But in hindsight, this fixture would also work to drill those holes. Maybe I don't need the other fixture anymore. It would even be nicer because this allows me to do this part without moving the table in X, Y at all. And overall, this will save me the hassle of setting up the indexing head each time I do these parts. Now I have a dedicated fixture only for these parts. So I just decided to ditch the other fixture, part it out, take out all the pins, and put the plate in scrap or in my stock rack. Okay, got the fixture clamped in the vise on the mill. I need a 1-2-3 block down here to space out the movable jaw because this pin is below the fixed jaw. I can either do the distance block here or use a parallel to raise it up a little bit. It's just what it is because this piece of stock wasn't big enough to move it all up. So I decided to go for the 1-2-3 block in here. I have the edge finder in here. I'm going to center the slot and touch off on this face here. There we go. Now we can switch to our actual tools and to a part. So this is still the demo piece. I will drill the 5mm hole now, all the way to the center. Then we take our pin, our index pin, we rotate the part, index with our pin between those two fence pins, drill the 3mm hole, do the same on this side, and be done. And all this without moving the XY table of the mill at all. So we can lock X and Y. We only have to move this and the quill. Spot facing with a 5mm carbide end mill so the drill doesn't run away because we're drilling through the face groove on the other side of this part. Switching to a long series Goering drill and drilling all the way to the center of the part. The final depth is not critical, it just needs to be about in the center where the hole stops. We loosen the clamp, rotate the part, insert the pin between the indexing fence and reclamp it. Now we go for a 3mm end mill, spot facing again. And instead of changing tools, I will spot face both of the holes before I change to a drill. Now I'm switching to a normal 3mm high-speed steel drill and drill all the way to final depth. Changing the index position. Drilling the other one. And we're done. So that's significantly easier than using the indexing head. The indexing head was always a little bit of a problem to set up. It's heavy, primarily it's heavy, and the indexing, you have to crank the hand crank quite a bit for that. I think it's 2.5 turns to go from 0 to 20 degrees, and then you need to go to minus 20 degrees, which is another almost 5 turns. Okay, I drilled all the radial holes. Now I set up the fixture laying down flat in the vise and already moved to my precision. And the way this works now, very simple. Part drops in and we get our index pin like this. And we just drill to depth. That works exceptionally well and quick. I'm fairly happy that I redesigned the fixture to do all the drilling on one fixture instead of using the indexing head and the old fixture. Okay, here's the stack of parts. All done, all within tolerances. Hope you enjoyed. Something different, something plastic this time. Thank you all for watching. Thanks for the support, and I'll be back.